In this mini lecture we're talking about alkane names, but now we're going to go from the structures to the names. So here's an example. Here's a structure, and I've drawn it over here as a line structure. The first challenge in any of these kinds of problems is to figure out what the base chain is. And the base chain is always the longest chain of contiguous carbons, that is, carbons that are all joined together. And you might have a bright idea and say, okay, here's the base chain 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. But 7 is not the longest possible base chain you could have. You can't go up here 1, 2, 3, 1, 2, 3, 4, 5. That's not going to work. So what we've got to do is wind our way through the compound. Maybe start up here 1, 2, 3, 4, 5, 6, 7, 8. And that will be the longest possible chain we can have. Our next mission then, after we've decided what the base chain is to figure out which way to number it. So what I'm going to do is I'm going to go down here, and I've got this drawn again twice here. Let's number this in different ways. First of all, let me circle the base chain. Okay, there's the base chain there. Now I'm going to number it. It'll be 1, 2, 3, 4, 5, 6, 7, 8. But we could also number it from the other end. So at this point we've got to decide which numbering is correct. The rule we use is that for substituent groups they need to have the lowest possible numbers that they possibly can. So if you look closely, what we have is we have a substituent group attached at 3, we have a substituent group attached at 4, and here we have a substituent group attached at 5. So these are the groups that are actually hanging off the base chain. See, I've circled the base chain here, and these are the groups that are hanging off those different numbered carbons. If we do the same thing on the other structure, what we see is this. We've got a chain hanging off 4, 5, and then 6. So clearly, since 3, 4, and 5 are lower than 4, 5, and 6, we're definitely going to go with the numbering where the 1 starts at the left-hand end of the base chain. So that's the first decision that we've made. The other way of looking at that is you can perhaps add the numbers where the substituent groups are attached, add them together, and see which one comes up with the lowest sum. This one comes up with 12, 3 plus 4 plus 5 is 12. This one's 4 plus 5 plus 6 is 15. So since 12 is less than 15, we'll go with this numbering here. Generally speaking, it's fairly easy because you can look at the chain and see, well, what end are they nearest to? And if you look at the substituent groups here, it looks like they're closest to this end rather than that end, so we know that numbering is going to start on this end of the compound. That's something you'll get a feel for sort of the more you do it. Well, the next challenge is to look at the substituent groups and then come up with names for them. And that's where these line structures come in handy. You can look at these and you can say, oh, okay, well, here's what these look like as line structures. So we'll be easily able to identify these substituent groups. This substituent group is an ethyl group. You know, it's got the line going to another line. That's an ethyl. Here's this one here, that's another ethyl group. And this one here, that's going to be this one, the isopropyl group. So it's not that difficult to tell if you know what the line structures look like. Alright, so let's go ahead and label those. So we've got an ethyl, we've got another ethyl, and we've got an isopropyl. Right, the next thing we need to do is to put these all into the name. We know what the base chain is going to be. It goes from 1 to 8, so that's going to be an octane. We automatically know that. The next thing we know are we have ethyl groups and we have an isopropyl group. The substituent groups go into the name in alphabetical order, ignoring any prefixes. And the prefixes I'm talking about are di, tri, and tetra. So anything that tells you the number of those groups that you have, that's not part of the alphabetization. The other thing that's not part of alphabetization are these kinds of prefixes like N and sec and T. Those are not part of the alphabetization either. Now it's easy to tell what's part of the alphabetization and what's not, because you've got N-propyl, sec-butyl, T-butyl. Anything with a dash in it is not going to be part of the alphabetization. Isobutyl, on the other hand, is part of the alphabetization. I would be considered to be the first letter of isobutyl because there is no dash in isobutyl. Right, so that's something that you've got to be keenly aware of when you're doing this. So we know it's going to be the ethyl groups that are going to go first, and we put down their location on the chain, and we have an ethyl group attached at 3 and 4. So we need 3, 4, then a dash, diethyl. Now when you're doing this, there's always commas between the numbers, and then there's a dash between the number and the next part of a name. Likewise a dash here because we're going to put another number in, and that would be for the isopropyl group. And we know the isopropyl group is at 5 on the chain. Five isopropyl, and octane is the name of the base chain in this instance. Alright, so let's go back to the example here. There you go. So you got the ethyl, you got the isopropyl. The name is 3, 4 diethyl, 5 isopropyl octane. Notice again there's no space in between the isopropyl and the octane. But look at the formatting. Commas between the numbers, dashes between the numbers and the name, or the letters in the name, and dash between the letters and the numbers as well. So all of that's got to be taken into account. Alright, let's look at a cyclic compound here. Let's look at this one as a line structure. No, so that's what that looks like as a line structure. Now the first thing we've got to realize is that the base chain is going to be considered to be the cyclic unit. So whenever you see a cyclic unit, always assume that to be the base chain. Since this is 6 carbons, the base chain is going to be a cyclohexane ring. Alright, the next thing we want to do is let's go ahead and circle the substituent groups. Those are the groups attached to the base chain, and what we've got is a methyl. We have an ethyl, and we have a propyl or N-propyl. I'll say N-propyl. You can use propyl or N-propyl in that instance. Now, as I said earlier, when you're numbering these, you're going for the lowest possible number. Now, as I've got over here, I've got this numbered a couple of ways. I've got it numbered from here as being number 1, 2, 3, 4. I've got it here as being 1, 2, 3, 4. And when you're choosing the numbering, what I like to do is start in the area of the compound that sort of has the most action associated with it, and that would be this region here. So I know the 1 is going to be somewhere around here. Now when I'm numbering, you number through the action. So numbering from here as being 1, 2, 3. Come on. Come on. 1, 2, 3, and 4. That would be the best way of numbering it, because that will give me the lowest numbers on all these substituents. If I start numbering through here, I'll go 1, 2, 3, 4, 5, and that'll be higher numbers. Obviously, numbering through here is not going to do me any good either, because that'll be 1, that'd be 1, 2, and that'd be 3, that'd be 4. And you have higher numbers than you would if you went through this way. So everything's got to have the lowest number it possibly can, and that's the best way of handling that. Right, the next thing you want to do is then name the compound, and again we use the alphabetization I was talking about earlier. So what's going to happen is that the ethyl group will end up going first, followed by the methyl, and followed by the propyl. Remember that the N doesn't carry into the alphabetization. It'll just be the E, the M, and the P, and then we go ahead and draw the name out, and it would be 2 ethyl, followed by 4 methyl, followed by 1 N propyl, followed by cyclohexane. All of this would still be one word. Alright, there's no space between the N-propyl and the cyclohexane. But again, notice the formatting with the dashes in between the numbers and the letters in the name, and no space between the propyl and the cyclohexane.